Hello and welcome to our latest on-demand webinar with the title Oops, I valved again. Or why does it make sense to focus on valves if it comes to Industry 4.0? My name is Nicolas Spiegel. I work for UReason, and in the next about 35 minutes, I will have the pleasure to guide you through our experience, through our thoughts, why it makes sense in the process industry, but also in the chemical, pharmaceutical, and energy industry to start with Industry 4.0 focusing on valves. I'm looking forward to your feedback, and with that, let's get started. To introduce Industry 4.0 and especially the challenges around Industry 4.0 faced by the chemical industry, by the process industry, but also pharmaceutical industry and many others. We very often, together with our customers and partners, use such a illustration. It's a basic flow you can find in many different industry. A liquid, a product flows from a storage tank with the help of a pump to a reactor. It's of course highly simplified, but it is very suitable to explain really the different challenges around Industry 4.0. Now, what I mean by challenges, if I start on the left-hand side, I have a tank. I know what I need to do in terms of inspection and maintenance with my tank. One, most of the time, is I have to enter the space, the closed space for inspections. I, of course, can use Industry 4.0 solutions like this drone here shown from Copterflug to help me with that. With these drones, I can completely avoid to send people inside the closed spaces. Great solution. If I go down the pipe, I can use a different great solution. I have a lot of flanges. Flanges needs to be tight. Leaking flanges are a big problem depending on what's inside the pipe. Henkel has developed Loctite Pulse, a solution that helps me to monitor digitally if my pipe is leaking or my flange is leaking. I will have valves or various kind of valves in this installation. A lot of the valves that are supposed to close, for example, the outlet of a tank, we know a larger percentage of these valves is not completely tight. There is an internal leakage. Sen7 from Austria, for example, has developed a technology that allows you to listen to your valve and monitor and quantify the leaks. Of course, I have a big plant, long pipes, lots of instruments. I can use robots, like these robot dogs, to do various tasks. I can use the dog, this robot dog, to check the position of a valve, but also more advanced things, when, for example, automatically read the manual dial here shown on the right-hand side. And of course, if I come to the pump and the motor, I have many more Industry 4.0 solutions I can use. For example, I can use wireless vibration sensors. I can connect them and monitor with very smart algorithms the condition of my pump. Here shown the Optime by Schaeffler. There are many more solutions doing more or less the same. I can go deep into my machine. I can use technology, for example, by BestSense to monitor the bearings, so the condition of the bearings. And if I move to the right, I can use advanced microphones for sound-based condition monitoring of my reactor vessel, for example, by Fallen systems. I can connect all my digital instruments in the plant, for example, to the Natillion cloud from Andreessen Hauser, and therefore monitor very nicely, very accurately maintenance requirements and condition of his instruments. And of course, if it comes to motors, I can do motor current analysis. Prominent example here is Semiotics from the Netherlands that offers hardware and software, allowing you to do motor current analysis for all your motors. Now, and last but not least, you can use the valve by UReason to do control valve monitoring. Now, what I'm showing here is not even 10% of the different possibilities you have in this small selection of process equipment and process to Industry 4.0 to make your work easier, to make maintenance smarter. Every single solution, of course, have competing solutions, and there are many, many more. There are really so many great solutions, making it difficult to choose where to start. That brings me to the wording I really like a lot, overchoice. Overchoice. Any expert looking in Industry 4.0 and trying to select solutions has the challenge nowadays of overchoice. Of course, I have not invented the wording overchoice. It comes from the book from the 1970s here by Alvin Toeffler, Future Shock. He introduced already the wording overchoice, having too many choices, and the dilemma based on that. Another nice book I really like, the title, The Paradox of Choices, and the key conclusion that there are more and more choices, and these larger amount of options are not really benefiting us. So, this is also very nicely, also the problem of too many choices, overchoice, is also very nicely reflected in our industry survey from last year. We asked customers and partners in the process industry a number of questions, and one was, what are the top 3 Industry 4.0 challenges? Number 1, not enough resources. And number 2, not clear where to start. And we then asked a little bit more in detail, and the conclusion was too many choices and not enough resources to evaluate properly all the different choices and make the right decision. Also, number 3, missing business case is closely related to that, because you need quite a few resources to calculate business cases for these different choices and to use business cases to make selection. So, top challenge is not enough resources to master the overchoices. How does it look like? Well, if you're an asset owner, digital expert, a reliability engineer, plant manager, continuous improvement engineer, asset manager, somebody in an operating plant who wants to look for, test, try, and roll out Industry 4.0 solutions. He is facing a wave, a huge wave of information coming towards him. And as you go deeper into the topic, you talk to more people, this wave is only getting bigger. You're bombarded with webinar possibilities. If you spend some time on LinkedIn and Google and search for the right keywords, you will at some point get back a lot of advertisement in this direction. You will get cold emails advertising Industry 4.0 solutions. Any fair nowadays, you go from booth to booth, you will see one great solution after another. You will get offered demos. You go to conferences and you listen to 20, 25 presentations. Again, great solutions, probably out of 25 presentations, you could straight away see yourself using 15. Huge amount of great solutions out there. If somebody gets your telephone number, people will start calling you nowadays. Offer fantastic solutions with great business models. Consultancy firms are compiling reports, comparing different solutions. And in the end, it is simply too much. And I've been in this position. I've contacted or had contact with many suppliers, and you're really triggering a wave or an avalanche of information, never ending contact requests with digital solutions. It is too much. Now, based on our extensive experience in the area of Industry 4.0 and based on countless projects we have done, we believe we have identified a shortcut. We believe that you can make a real step change in the process industry in terms of Industry 4.0 if you simply start with control valves. Pick the control valve and start your digital journey with the control valve. Of course, the question is why. In the next 3-4 slides, I will try to take you through our experience and through our reasoning, why we believe, and of course, how you can start with control valves. The first thing is, let's start with our story and our learnings. We did not wake up one morning and say, hey, control valves are great, let's start with control valves. It was a gradual process driven by the unique opportunity to do a lot of different projects in the beginning, mainly with manufacturers and suppliers of valves. You see here some examples: Krone, Samsung, AS Schneider. You see here the probably most modern control valve, a focus on one valve with our software in it. Plus, we have a test center, and we work together with OEMs and suppliers and manufacturers who come to our test center, install valves and actuators, and run tests to develop tools and algorithms for Industry 4.0. So step by step, we started to do more and more projects around valves, control valves, and actuators. And we learned a couple of things. The first thing we learned is that there is very little actual control of valve and actuator health or actuator condition outside of the inspection windows. Sure, you have half a year inspection windows, you have turnarounds maybe every 4 years, but in between, you are more or less blind. You don't know much, and you don't know much about the condition of your actuator and your valve, and therefore you're also surprised if something goes wrong. The second thing we learned is there's a lot of blind maintenance and replacement happening. And by blind maintenance and replacement, I mean actions and activities not based on the actual needs. Things like every 15 years, every actuator or every valve is being replaced, or maintenance based on a fixed schedule, and not based on the actual needs. It's time consuming, it consumes a lot of money, and it is not targeting the actual needs in terms of asset condition. And the last thing, and what in the end triggered our development, is we learned that hidden in the movement patterns of valves and actuators, by design, a valve and an actuator, they move, they go open and close. And the changes of these movement patterns over time, hidden in there, are information about failures, upcoming failures, and the actual condition. What do I mean by that? How does that work in detail? You have a control valve or valve. It moves. Here, traditional control valve moves up and down, but it works exactly the same if it's a rotary movement and the valve is moving in different directions. It's movement of a valve. This movement is recorded over time. There are two things that happen over time. It's the position where the valve is supposed to be over time, and it's a position where the valve actually is over time. 2 data points. They are always directly or indirectly, but they are always accessible via the DCS, via the control system. So every single control valve operating out there, you can access these 2 data points directly or indirectly. This movement over time can be compared to music. It is really the music, the sound of your control valve. And exactly like in music, you have recurring patterns. You have a melody that distinguishes the music from noise. You have patterns that reoccur. You have patterns that change over time. And what we did is we developed a set, it's a network actually, a network of algorithms. Some of the algorithms are AI algorithms, some are expert algorithm, but it's a network of algorithm that is capable of listening to the music of your control valve, to the sound of your control valves, and detecting these various patterns. As a result, our algorithm is capable, for example, to detect failures. Is there already a failure, a significant failure happening in the valve? Each failure corresponds to a pattern in the movements. You can recognize that. Also, you can not only detect the failure after it had happened, but you can also detect the onset of a failure. So before the failure is happening, something in the music of the valve is changing. You can detect it and generate early warnings. Also, the sound of the valve, if I might call it like that, the movement over time, the patterns are changing. It's different first month, second month, third month, fourth month of observation. Things are changing. And these changes in movement in the sound of a valve can be used even to predict the remaining useful lifetime of the valve and the actuator quite accurately. As a result, listening to this music of the valve allows for less inspection. You can reduce the scope of the turnarounds. It allows for better maintenance planning, better investment planning. You even can save energy. Control valves by design destroy energy. Better control valve condition saves energy, significant energy. You can reduce production losses, and many more nice things can be done by being able to listen and interpret the music of a control valve. Now, this obviously, there are much more details than I can show you right now. Let me mention at this point, we're always looking actively for partners, experts to discuss. So please contact me after listening to this video, after watching this video. I can organize a detailed demo and we can look at it and discuss it really in detail. Also, we offer the opportunity for a free test. So you can give us the data of your control valve, and basically our algorithm will allow you to listen to your control valve, to listen to the music of your control valve. Okay. At that point, I talked a lot about control valves, but I started my presentation by looking at the various options you have to start your digitalization journey. If you today go to a trade fair or so and you look around, you will find a lot of digital solutions around pumps and motors. So at this point, I think it's really important to compare the different aspects if it comes to Industry 4.0 regarding pump motor and control valve. If we start with inspection. Traditional inspection of a pump and a motor can be done nicely, vibration analysis, while the plant is running, or should be done while it's running actually. So during operation, no effect on your operation. Control valve is very different. If you want to use traditional means of doing a meaningful inspection of a control valve, it at least requires you to stop the section of the plant and to take the control valve out of operation. Next point is failure detection. In a lot of plants, you still will find that rotating equipment and pumps, failures can be really detected by experienced operators, experienced maintenance people, by just walking through the plant and hearing a change in noise. Yes, I know if you can hear the change in noise, it's already quite late, but it is a failure detection before the failure leads to a shutdown. Valves are very different in this sense. Control valves, very, very rare. You can hear failures in control valves. Control valves, we call it fail quietly. It's a silent failure. They fail and more quite often lead to expensive shutdowns. Failure consequences. Also here is a huge difference between pumps and valves. Every large important critical rotating piece of equipment today is already extensively monitored. There's no one who runs a critical piece of rotating equipment without extensive monitoring if there's no backup. The smaller ones, especially chemical industry, smaller pumps, for example, most of the time are in A and B configuration if they're critical. So there's always a backup. If A fails, you can still run B. So failure consequences here are manageable. For valves, it's different. The AB configuration for control valves, yes, you can find it sometimes, but it's not as widely used as AB configuration as for pumps. So any failure, critical failure in a control valve, most of the time requires you to shut down the section of the plant and do something about it. Another interesting difference if it comes to Industry 4.0, any meaningful condition monitoring or predictive maintenance of pump or motors requires additional sensors. You at least have to install a vibration sensor or install hardware to do motor current analysis. For control valves, and I just explained it, we found out that the data used to run a control valve, so the set point of a control valve and the actual position of a control valve or a control variable, give you all the information you need to do comprehensive diagnostics. And that's quite unique, that you already have all the data you need. At this point, I would like to go back and look again at some results from last year. What are the top 3 strategic maintenance priorities? So what does top management or the experts give out? This is the priority for our maintenance in the next years. And the answers we got back are pretty clear. I did not expect it, to be honest, but the direction is very clear. Number 1 is do more with less. And that basically means, if you ask further, technology will need to replace people and expertise. How does it look like? If you look at the simple graph on the right-hand side, today you maybe have 20 people. 20 people, if a problem happens, you have plenty of manpower and especially plenty of know-how and expertise across your 20 people to confidently take care of a problem in a timely manner. Tomorrow, for sure, you have less people. Hiring is really difficult. Tomorrow, there will be less people, but still manageable. However, in the near future, very soon, there will be much less people and much less expertise available to deal with the same problem, the same amount of problem and tasks. So it's very clear that not only the manpower itself, the hands, basically, hands-on tools, but also the expertise needs to be replaced and complemented by technology, by Industry 4.0 solution. And this is basically where the strategic priority comes from. Use technology to be able to do more with less. And to be very clear here, the goal is not to fire people and replace people, to save money and replace them with technology. Not at all. The challenge is there are not enough people and not enough expertise in the future, in the near future, available to do the same task as today. Now, summary. what did we and what did I learn over the last years in this journey and in this presentation as well? I started with many great solutions with positive business cases. There are really a lot of great solutions out there. And if you send me as a consultant into a plant and I talk to the people, we can identify easily 10 solutions you can implement tomorrow with a positive business case. So it's not a business case, that's a challenge, but there are lots of great solutions. However, if I identify 10 solutions, by no means a plant has enough resources to evaluate, test, and roll out all these Industry 4.0 solutions with good business cases. It takes substantial resources, especially during testing and rollout. At the same time, the trend is accelerating. There is a need to do more with less, and there will be a significant reduced workforce of maintenance operation. Kind of a double problem already today. Not enough people to evaluate and implement new solutions, and in the near future, even less people. A lot of these great Industry 4.0 solutions require new hardware. Be it smart glasses, new sensors, new technology, new hardware is required by a lot of different technologies, Industry 4.0 solutions. Hardware, however, has the problem installing and maintaining new hardware requires a lot of manpower, critical manpower you don't have today and even less in the future. So new hardware is always a big challenge. Therefore, and that was our learning in the end, drove us to develop the control valve app. It is a huge advantage if you can introduce Industry 4.0 solutions that help you to do things better, cheaper, with less people. And if these Industry 4.0 solutions work with what you already have available, no need to install a sensor, cable, hardware, whatever. And the second thing is not only work with what you have already available, but also integrate easily in your existing workflows. Now, I started my presentation. I started with this video, with this slide, and I had the question where to start. Now, we believe the answer is in many cases, not in all cases, but in many cases, it's a great place to start with your control valves. Your control valves allow you today to make a step change in digitalization of maintenance and maintenance activities. Many great solutions out there, but especially control valves allow you to make a big change and have a big impact, not only on the bottom line, but also on your resources. At this point, I'm talking about myself, I'm talking about UReason. So what and who is UReason? UReason is a software company from the Netherlands. We are specialized in Industry 4.0. We have our head office in Rotterdam in the Netherlands and some offices in the UK for our developers. The founders of UReason have individually more than 20 years of experience with condition-based maintenance, predictive maintenance, and data. That means even before the whole Industry 4.0 revolution started, they already developed predictive maintenance solutions, for example, for refineries in the oil and gas industry. We are a software company. We have one piece of software. We have a software platform, a low-code software platform we call APM Studio. This platform is used by us and our customers to develop apps for condition monitoring, predictive maintenance, digital twin, and alarm management. Our customers and partners are machine builders and now also asset owners. And we do projects all over the world, but we are smaller companies, so most of our projects are in Western and Northern Europe. But you can see on the map on the right bottom, our projects really can be in different areas of the world as well. Now, I mentioned apps here. Let me explain, using the example of control valves, what I mean with develop apps for Industry 4.0. If you take the control valve, if you look at the control valve app, what I mean by app, it's really the algorithms here in the orange box packaged into a software, what we call an app. This is an Industry 4.0 app. Algorithms that on the left-hand side take data from a process, in this case, a set point, valve position, or control variable. They then analyze this data, and the app is producing results. In this case, condition and recommendations for the control valve. And the software containing this algorithm is an app. It's not an app you can download on your phone, but it's an app you can run where you normally run algorithm for diagnostics. You can run it in the cloud, you can run it on a server in your plant, or you can run it on an edge computer, for example, very close to the data where they are produced. This is an app. And my last slide, again, summarizing why the control valve app is such a pragmatic tool to make a step change when it comes to Industry 4.0. First of all, it's plug and play. It means you plug it in and it works, because everything you need, the 2 data points you need to use the app, you already have. You have a control valve, you have the data you need. Secondly, it works really with every single control valve in your plant. Air, electric, hydraulic, actuator, and different type of valves. So you don't need to make selection. Okay, it only works with the latest valves or with the valves in this plant. No, it works with every single actuator and valve in the plant. The third thing is it provides actionable insights. Really important. That means it neatly and immediately integrates with existing workflows. The results you get are actionable to a degree where you can generate work orders with it. You're not only getting an alarm like condition is deteriorating. Okay, what does that mean? Do I need to do something? No. The control valve app is capable of giving actionable insights, meaning telling you what exactly needs to be done, and automatic generation of work orders. That's where the journey goes towards. This is my last slide for this on-demand webinar. Just in the end, the contact information, and again, our desire, we would like to talk to you. We would like to increase our network, exchange with experts from the process industry or from other industry, talk about digitalization, find out what you think, where your problems are, what your experiences are. So I'm always looking forward to hear from you. Write me an email, connect with me on LinkedIn, or give me a call. And I really hope you learned something. I could share some valuable insights with you. And yeah, looking forward to maybe see you in an online meeting, or maybe see you in person very soon. Bye-bye.